Okay, so welcome to the second meeting of Berkeley Cybersecurity Club. Happy Pi Day, everyone. And I hope midterms went well or is going to go well. Today, I got a pretty cool presentation on one of the most prolific bugs that has happened in the past year. And it's actually pretty crazy. Many of you guys might have heard of it. Have any of you heard of Log4j, the vulnerability? Okay, yeah, that's around half of y'all. It was pretty much a super catastrophic exploit and vulnerability that's happened. And it was just discovered last year, the last half of last year, towards the holiday season. And how it works and everything, what makes it super dangerous is that the Log4j vulnerability was super easy to exploit. And it affected a piece of software that was run on like so many different vendors, products, and a bunch of enterprises. So it's pretty crazy. So if you haven't, I've went through this slide a bunch of times, but please download the lab if you haven't, or if you want to follow along and do Log4j stuff on your computer. All right, let me hide this. All right, cool. So the Log4j vulnerability is also known as LOG4SHELL, and it was given the CVE 2021-44228. And essentially, this vulnerability allowed attackers to execute code on a target system. And as you can imagine, that's pretty bad. And that's also what's known as remote code execution, or RCE. And essentially, it affected millions of people across different software, platforms, and products. And many have actually described this as the largest affecting vulnerability ever known to date. And the severity of this was given a score of 10 out of 10 by CVSS, MITRE. And we're going to get into it and see why it was really bad. So Log4j is a software component, a library written by the Apache Software Foundation. So that means it's open source, it's free software, and it was created back in 2002. And essentially Log4j is a very popular Java logging tool. So when you're debugging, in 61B, you might have done a lot of system.out.println to debug your software. Or if you're creating like a web server or something, you want to log who gets into your server, what IPs they're coming from. Generally, they would use Log4j. And what makes Log4j much better than system out print and other debugging software is that it's very efficient. So it scales really well. It's very good with concurrency issues, very extensive in features. And essentially, it's got a huge community of users using a whole different set of products. And it has a lot of support. And essentially, yeah, it's like free software and it's very highly updated. Any question on what Log4j does?
Is there a link to this?
Yes, it's on the website. Okay, so essentially, it's logging software, right? And a lot of developers might incorporate it into their software and think nothing of it. They just start using it. It logs stuff. It works fine. And in a lot of these companies and products, they use Log4j. If they're running Java, they're most probably using Log4j. And as you can see in this little diagram right here, you have your modern tech stack with a whole bunch of components and libraries. And then you have that one little sliver, which is Log4j. You think nothing of it, right? And essentially, all these companies use it. Minecraft. Many of you guys have heard that Microsoft's Minecraft has been affected by Log4j. And it was actually the most popular use of a Log4j vulnerability. Amazon AWS, Twitter, NSA Software, Ghidra was affected. Tencent, Google, Tesla, all of these companies. So essentially, a whole bunch of different products use Log4j. And here you can see, can you see? Can you guys see in the back? Okay. All right, well, essentially what it's doing is you're kind of creating like a logger, and then you can basically print stuff to the logging object, right? So if I wanted to print out an error, I would just do logger.error and then a string that goes into it, and that would essentially print out something into the console. So that's a very simple usage of log4j. And how could something like this basically cause, havoc on the whole tech industry? How could you essentially, print something and then have it cause remote code execution, cause millions of dollars of damages and stuff like that? And this is where we're going to have to go on a little tangent on a couple of technologies that y'all might not have heard of before. So the first one is called Lightweight Directory Access Protocol, or LDAP. And it's essentially a communication protocol that allows users and enables users to access certain directory services. And directory services are these things, and to put it into simpler terms, it's kind of like a database of things like email services, user accounts, basically what you see there, license management. And LDAP kind of authorizes users and points them to the right direction of where their directory service is. So if you're on the Berkeley network and you're trying to send an email, what happens in the back end is your Berkeley account gets authenticated by LDAP and it points your email in the direction of the email service hosted by berkeley.edu. Okay, and to interface with LDAP and to do all this communication, we have this thing called the Java Naming and Directory Interface. And this essentially allows Java programs to kind of communicate with LDAP servers and much more, DNS servers, RMI, and stuff like that. And essentially, when you're in a Java program, you just use this JNDI interface, and then you get to do a bunch of communications back and forth with the server. Do you guys have any questions so far on how all this works? So if you're thinking from like an attacker standpoint or from a hacker standpoint, you might think, oh, what if we controlled an LDAP server, pointed it over to a malicious Java object, and then have a Java program use JNDI to request that Java object and run arbitrary code? So that's essentially what you can do with log4j. Log4j just so happens to have a JNDI interface that allows you to communicate with an LDAP protocol. So what we have here in the bottom is, we're creating a logger. It's called logger1. And then this string right here is attacker controlled. So for example, if you're on a Minecraft server and then it's logging a bunch of messages, it would take this string and then call logger.error or logger.info or logger.message or whatever, and basically execute that piece of string. And essentially right here in this string right here, we have JNDI, LDAP, and then the server host, and then the port, and then the resource that we want to access, right? And this basically tells log4j, I want to use the JNDI interface, and I want to communicate to an LDAP server hosted at localhost 1389 and access the object exploit. And that's essentially what that does. Any questions?
Well, like in this example, it's localhost, but in a real example, the on a web server that has some arrays.
Yeah.
This is running on there.
Exactly, yeah. So essentially, if you were attacking like an actual public domain program, you would have it set to like a public IP, some of that hosts on an AWS, Google Cloud, or whatever. And it wouldn't be pointing to a web server, it'd be pointing to an LDAP server. And that LDAP server can then eventually point to a web server to download stuff like that. Yeah. All right, so we're the attacker, and we're going to draw like a schematic on how our attack works. So here we have a target application. It's running log4j, and we have a user message, right? Pretty standard. Think of it like a Minecraft server. And we know that the user message is attacker controlled. So we have complete control over the contents of what the user message is. And we know that the target application is going to call logger.info or logger.error on our message. So essentially what we do is we create an LDAP server, host it on our own website, host on AWS or the Google Cloud. And we open the port and stuff. So then the target application can eventually access it. And then we create an HTTP server. And that essentially holds a resource called exploit.class, or our Java object that we want to send over to the target client. All right, so what we do as the attacker is we send in this string, JNDI, LDAP, the host, and then the port, and then the resource that we want to access, right? So then we send this over, and like we said before, Log4j interprets this string as a lookup for our LDAP server and the exploit associated with it. So then you have, it's asking the LDAP server, hey, please give me exploit. And the LDAP server, what we have set up, tells the target application, make a request to this HTTP server, and then you have exploit.class sent back. And what makes this incredibly stupid and very, very powerful is that Log4j will then take this exploit.class that it's requested and then automatically runs it and completely trusts it. This is very, very, very stupid. Like if you're like a software developer, or if you're doing like, some kind of system design, you never want to trust user input, and especially not user input that you go and try to execute without verifying what it is. So yes, that's essentially what happened. Yes.
So to be clear, like the Log4j target application makes 2 requests to servers in succession, like one request to the LDAP server, then another request to the HTTP server.
Yeah, so this is a very high level view, but yeah, that's essentially what happens, right? So the JNDI interface asks the LDAP, hey, do you have exploit.class? LDAP says no, but I know someone who does, which is the HTTP server, right? That's what's known as a referral in LDAP. And essentially Log4j is like, okay, I'm just gonna go ask this HTTP server, and it downloads all of it and then runs it.
Is it also a problem that Log4j, when given like the JNDI, will run that command as a command and not just interpret the message?
Yeah. So this is actually a feature. Yeah. So JNDI also includes a lot of other stuff. So if we go back here on the bottom, you see like DNS, NIS, RMI, and stuff like that. All of those are attack vectors that you can use to kind of exploit stuff. And a lot of people say, oh, this is a problem with the Java, the language itself, and JNDI. But this is essentially an issue with Log4j, as in they're trusting this user input. They're trusting this JNDI lookup and executing what it wants. Did that answer your question?
Yeah.
Okay, cool. So yeah, hosting like an LDAP server is not the only attack vector. This is just one of the most easiest ways to gain remote code execution onto your target application. All right, so we have exploit.class. You might not know what it is, but it can literally be anything you want. In my example right here, I have, it just runs like a command line. Yeah, it just runs like a command line command, and it opens up the calculator app on my computer. You can change this to be anything you want. You can remove the root directory or whatever. You can cause a reverse shell, anything you want. So essentially, the attacker, depending on the privilege level of the target application, it can do whatever it wants freely, as long as you have remote code execution. And that's very dangerous, as many of you may know. And oftentimes, getting remote code execution on iOS or Mac OS or Android and stuff like that, those bounties go for millions and millions of dollars in the black market. So this is a pretty serious vulnerability. And here, this is essentially what happens. A nice little diagram that someone else drew. Any questions? This was very confusing to me when I first saw it, so. Okay. All right, and here's a quick demo of kind of what happened or what happens when I try to do this. So right here on my left, okay. Right here on my left side, I'm going to be running a I'm going to be running an LDAP server. So I'm setting this up. And basically what this is like a .jar, and that's basically an LDAP server written by someone else. I didn't want to deal with all that. And this is basically telling LDAP that whenever you receive a request, point it to localhost port 8000, and that contains our exploit, which is the HTTP server hosting our exploit. So I'm going to be running this. And this is now my LDAP server. It's listed on 1389, port 1389. And anytime someone connects to port 1389 and makes a request, it's going to refer the program over to the HTTP server. And right here is my HTTP server. I'm going to allow all connections. And basically this hosts my exploit. All right. And then over here, I have a log4j application. We're creating a log4j logger, and then we have an attacker controlled string. And again, like you've seen before, it's basically saying JNDI, LDAP, and then the localhost 1389, which is our LDAP server. And then it's requesting a resource called exploit. And what LDAP is going to do is it sees this request from log4j and says, oh, why don't you ask the HTTP server where this resource is? So it makes a request over to the LDAP server, and then it makes a second request over to the HTTP server, which I have running on the right side right here. So if we run this, what's going to happen is the target application runs, and then I see a calculator pop up. And this, for those of you who are a little bit confused on why I chose a calculator, this is kind of like the universal language in cybersecurity on gaining remote code execution. So as long as you have a calculator open, you can do anything. All right, so then if we look at our LDAP server to the left, it saw that my log4j application requested for exploit. So what it's going to do is redirect the JNDI interface to ask for exploit.class in my HTTP server. And then on my HTTP server, it sees that the program is getting a request for the exploit.class and is setting that over. Any questions on the process so far? So yeah, that's basically it. That little piece of vulnerability caused millions and millions and millions of dollars of damages, caused a bunch of remote code execution and everything. So it was pretty crazy. And how it kind of turned out from a cybersecurity responder standpoint is actually also very crazy. So kind of the whole timeline of everything, what happened was, let me write this, was November 24th, 2021, Chen Zhaojun of Alibaba Cloud Security disclosed this to Apache. And 2 days later, it was assigned the CVE, which is, CVEs, if you guys don't know, is a vulnerability identifier. And it's hosted by, it's like a huge database with a bunch of exploits and vulnerabilities on popular software. And it's maintained by MITRE, which is a government contracting company. And it's basically the industry standard for identifying which vulnerabilities and what types and stuff like that. And November 26th was when it was first assigned to CVE. So no details of this exploit was kind of out yet. And December 1st, 2021 was actually the first time that it was discovered by Cloudflare, I believe, to be exploited in the wild. So you have people that discovered what this vulnerability was and kind of exploited it. And then they're running a bunch of scanners, running a bunch of automated log4j exploit, things, and Minecraft servers were all affected. This was first discovered in December 1st, 2021. 8 days later, Apache released the patch, log4j 2.15. And then on that same day, an exploit proof of concept was released. So what that is someone basically released code that allows anyone with no programming knowledge to kind of just throw it at a specific server or a program, and it causes remote code execution. So essentially that caused a whole widespread use of the exploit. Yeah, basically everything went to shit at that point. And then on December 10th, 2021, it was given a vulnerability score of 10 out of 10. And essentially, the timeline of how everything happened, it was very inconvenient for the people in the tech industry, because this was also when people were going off on their winter, like Christmas breaks, holiday breaks, and I believe when it got really bad was on Friday. So people who went back home on Saturday or Sunday, they had to be working overtime to kind of respond to this emergency. You had software engineers patching all these little, all these Log4j stuff. A lot of people doing hot patching, a lot of people updating dependencies, and this thing breaks and that thing breaks. It was kind of a whole mess. And essentially, it's still going to be a problem for years to come. It's very hard to update software, especially if it's kind of like this huge, monolith that, Amazon and Google's building, right? Yeah. Yeah, so one of them was literally telling Java not to execute code from an LDAP server. So that was number one. And then there were another one, there were like multiple variants of this, right? So other people can make DNS lookups. So essentially this pings a server, an attacker controlled server, and you can kind of gain information about their web service. They patched that. And there's a whole bunch of variants, you can look it up later, but essentially the number one thing was not executing code. Yeah. Right, so essentially, yeah, this ruined everyone's weekends. Their cybersecurity Twitter went off. It was a whole mess. And lastly, Log4j 12.7.1, I believe, is actually the safest version that you can use for Log4j. And it might have, I believe it was released earlier this year, 2022. And you can see here, the graph, this was recorded by Unit 42 of Palo Alto Networks. I'm not sure which specific network that they were analyzing, but it does kind of show the general trend of how people were exploiting this exploit. December 10th was, kind of when they first started reporting it, and just goes up exponentially. It's kind of crazy. You might not be able to read the numbers, but you can see the graph. And, everyone's day was ruined, right? So on the top left, you have the NSA director saying, this is a pretty bad thing. You have someone on Twitter trying to exploit Log4j in the Twitter servers, which is pretty funny. Minecraft, a lot of released a security patch. Tesla was actually affected. So you can see Tesla cars, someone from, I believe it might have been Tencent, that actually were able to get a Log4j string onto Tesla and then make a DNS request over to this website you see down here. AWS, Amazon products. This was actually just a screenshot. This whole thing is like 5 pages long. And it's just a whole bunch of Amazon products getting affected and how they had to patch everything. And of course, LinkedIn. This was really stupid. It was like, you enter like a Log4j string onto like the people search, and essentially you could ping back the LinkedIn servers. I don't believe there was remote code execution on LinkedIn, but it was, this kind of shows that this was very vulnerable. There were still other variants available. Yeah.
Is there a way, like, say you have a victim, is there a way to tell if, like, what version of Log4j they're running, or if they're running Log4j at all?
Yeah. So usually, it depends on if the target application is running like on an open port, running publicly. This is more kind of pen testing stuff, reconnaissance that I'm not too familiar with, but there usually is a way. For example, someone on iPhone they type their iCloud name or something using like a Log4j string, and then it pings the Apple servers, and then it receives back like the Java version number that iCloud was using. So that's one way to kind of identify who runs Log4j. Another one is if it runs a Java, if a company runs a Java application, most likely it uses Log4j. Yeah.
So was it annually user input? Or was it like specific ones?
There, it's like specific ones that that go through Log4j, right? So if, for example, this LinkedIn search, Log4j is probably logged in, right? So that's vulnerable, but any other user input that's that doesn't go through Log4j, it's not affected.
What did you mean by like paying the servers for Tesla and LinkedIn? Like, what exactly did that do?
So you can make a DNS request. So that basically kind of, DNS requests basically you're kind of asking a bunch of servers, where certain domain names are located across the internet. That's a very high level view, and I probably butchered that, so don't quote me on that. But essentially, like in this case, in the Log4j exploit, what you could do is you could cause the target server to make a DNS request to an attacker-controlled server, or dnslog.cn, and that essentially lets you know who pinged this server, and where they're located, their IP and stuff like that.
Do you know how long has this vulnerability been there before?
Yeah, so Log4j2 came, so this only affects versions Log4j2 all the way to Log4j 2.16. Log4j2, I believe, came out 2014. So this was vulnerable for around 8 years' time. And it's very likely that someone knew about it, kept exploiting it, or gave it off to someone for them to use or whatever. But essentially, the guy from Alibaba was very responsible and disclosed it to Apache, and that's how we all know about it today. Yeah. Cool. So you guys downloaded a file earlier, and that contains the Log4j kind of lab setup exploit server. So there's a README in there. You can kind of open it, check what's up, and there are directions on how to run this whole thing. And you could essentially try to use the Log4j string to kind of get remote code execution on your own computer. And if you really wanted to, you could open up the port and let people exploit your computer, but that's generally up to you. And if you guys need any help, let me know. Okay.